Question 6 of this exercise says, prove that the sum of the squares of the diagonals of a parallelogram is equal to the sum of the squares of its sides. So let's draw a figure to understand this problem statement. So here's a parallelogram ABCD that I have drawn, and let's also draw the diagonals of this parallelogram. So one diagonal is AC and the other diagonal is BD. So we have to prove that the sum of the squares of the diagonals, so sum of the squares of the diagonals is equal to the sum of the squares of its sides. So what we have to prove, let's write it here, is that the sum of the squares of the diagonals, which will be AC square plus BD square, this sum is equal to the sum of the squares of the sides, which will be AB square plus BC square plus CD square plus DA square. Okay, so this is what we have to prove. Now to prove this result, we are going to use something that we proved in the previous question of this exercise. Let me recap that for you. Let me recap what we proved in the previous question. For that, observe this figure that I have drawn, in which PQR is an arbitrary triangle and PS is the median from P to the opposite side QR. So basically QS and SR, they are equal. So the result that I'm referring to says that if you add PQ square and PR square, so if you take this sum PQ square plus PR square, this will be equal to twice of the square of the median drawn through P, so twice of PS square plus half of the square of the opposite side, opposite to P. So the side opposite to P is QR, so half of QR square. Okay, so let me recap, let me repeat this result once again. If we take PQ square and if we take PR square and add these two squares, we will get twice of PS square, the square of the median, twice of the square of the median, plus half of the square of the opposite side. So this result is what we are going to use to prove what we have to prove in this question. Okay. So what we are going to do now is we are going to apply this result to triangle. So observe the figure carefully. I am highlighting some triangles in the figure on the left. So we'll apply this result to triangle ABD, then to triangle ABC, then to triangle BCD, and then to triangle ACD. So we will apply this result that I referred to from the previous question to these four triangles that I highlighted. Okay, so let's begin. So let's take this point of intersection of the diagonals to be the point O. So because ABCD is a parallelogram, the diagonals AC and BD, they bisect each other at O. So AO will be equal to CO and BO will be equal to DO. So this is something that we can assume. Okay, now let's apply this result that we talked about first to triangle ABD. Okay, so in triangle ABD, so because O is the midpoint of BD, we can say that AO is a median for this triangle, correct? So the sides AB and AD contain this median. So this median AO originates from the vertex A, which is common to the sides AB and AD. So if we take AB square plus AD square, then according to our result that we saw, this sum should be equal to twice of the median square, so twice of AO square plus half of the square of the opposite side. The opposite side to A is BD, so half of BD square. Okay, then let's go to triangle ABC and apply the same result. So in triangle ABC, BO is a median from B to the opposite side AC. So in this case, if we take AB square plus BC square, the sides originating from the vertex B, if we take this sum, this will be equal to twice of the square of the median, so twice of BO square plus half of the square of the opposite side, which is half of AC square. Okay, then similarly let's go to triangle BCD. So in triangle BCD, we have CO as a median because O is the midpoint of BD, so CO is a median. So in this case we will have BC square plus CD square, the sides the sides originating from the vertex C. So BC square plus CD square, this will be equal to twice of CO square plus half of BD square. Okay, and then finally we will apply this result to triangle ADC. So in triangle ADC, DO is a median from D to the opposite side AC because O is the midpoint of AC. So therefore, if we apply the result to this triangle, we will get CD square plus AD square. CD and AD are the two sides originating from the vertex D. So CD square plus AD square will be equal to twice of DO square because DO is the median from D. So twice of DO square plus half of the square of the opposite side. So half of AC square. Okay, so these four results follow by applying these four equations that we've written. They follow by applying the result from the previous question to each of the four triangles that we saw. Now what we are going to do is, because we want the sum of the squares of the four sides in the result that we want to prove, we are going to add these four equations that we have written. So let's call this equation 1, let's call this equation 2, and then this is equation 3, and let's call this equation 4. So we are going to add these four equations. So what will we get if we add these four equations? On the left side we have AB square and AB square twice, then BC square and BC square twice, then CD square and CD square twice, so AD square and AD square, so AD square is also coming twice. So let's write this. So by 1 plus 2 plus 3 plus 4, by adding the four equations, we will have, on the left side we will have all the side squares repeated twice, so twice of AB square plus twice of BC square plus twice of CD square plus twice of AD square, correct? Now what will we get on the right side? So let's go back and see what we have on the right side. So on the right side we have twice AO square and twice BO square, twice CO square, twice DO square, and we also have half BD square and half BD square, that will add to BD square, and then half AC square and half AC square will add to AC square. So let's write this sum on the right side. So on the right side we will have twice of AO square plus twice of BO square plus twice of CO square plus twice of DO square, and then we have AC square and we have BD square. Okay, now if we observe the terms on the right side carefully, we have 2AO square and 2CO square, but AO and CO are equal. So if we write 2CO square as 2AO square, then these two terms will add up to 4AO square, correct? So 4AO square, and then similarly if we take 2BO square and 2DO square, and BO and DO are equal, so if we write DO as BO, then we will get 4BO square, and then we have AC square, and then we have BD square. Okay, and now 4AO square can be written as twice AO whole square, and 4BO square can be written as twice BO whole square, and then we have AC square, and then we have BD square. But now what is twice AO? Twice AO is simply AC and twice BO is simply BD. So this term, the first term, is AC square, which will add to AC square to give us 2AC square. So 2AC square, and similarly this term, the second term, twice BO whole square, is BD square, and BD square plus BD square will be 2BD square. Okay, and now if we look at the left side, in the left side we have the factor 2 common to all the 4 terms, and on the right side also we have this factor 2 common to all the two terms. So we divide by 2 on both sides. Okay, divide by 2 on both sides. So then on the left side we will get ab square plus bc square plus cd square plus da square. And what will we get on the right side? On the right side we will get ac square plus bd square. So on the left side we have obtained the sum of the squares of the 4 sides, and on the right side we have obtained the sum of the squares of the diagonals, and we have proved that these two are equal. So this is what we had to prove, and this completes question number 6. To learn more about how QMath can help you crack school and board exams, explore QMath Leap, a live online classroom program run by highly experienced and committed teachers.